Hello, welcome. My name is Dave Hanks. I'm the owner and vice president of Interlink Supply and Test Manufacturing. With me is Greg Barnett, who is our lead technician on research and development. Greg will come back in a few minutes and describe the operations and how to program our new product, E-Tes SD. So we'll excuse Greg for a minute while I go through a few of the features and then again turn the time back over to Greg. We're excited to be here and introduce this new product. I assume that many of you are familiar with TES and E-Tes. TES is our thermal energy system that is a trailer mount unit that has revolutionized the drying system. It dries most jobs in a half to a third the time as traditional systems. A few years after we introduced TES, we introduced the new E-Tes, E standing for electric thermal energy system. We're excited here today to introduce the new E-Tes SD. SD stands for Smart Dry. We've added some new intelligent smart features to the system so you can now monitor, control, document, as well as dry faster. So I'd like to just review a few of the features with you in this new product, the E-Tes SD for Smart Dry. The first thing we've done with the E-Tes is we've turned it into a computerized system and with a microprocessing board. The microprocessing board is obviously hidden behind the panel here, but you'll see a new complete control board with it here. I'll be going over those in just a minute with you. This has a built-in hour meter now. It also has a built-in humidistat that will read the humidity and a temperature sensor. Those are part of the system. So again, as we go along, it's going to now not only monitor those and register those, but you can now document them and data log them at the same time. We have in our system, you're looking here at our two different models, and we'll leave this up to Greg a little bit more, but we have the 240 volt model, he'll show you that, and then we have the 120 volt model, which is a dual cord system here. He'll go over the operation of that in just a minute. The first feature I'd like to tell you about is the moisture content sensor. I have one here on the table. This is the typical small probe unit. We also have hammer probes that can be hooked into the unit. You'll be able to see here shortly we have two receptacles, a sensor 1 and a sensor 2. So what this allows you to do is actually plug the receptacle, plug the unit into one of the receptacles, and then with the probes inject them into the material, the porous material that you're trying to dry. Again, that might be hardwood, any type of substrate, I guess, for that matter. Let's assume that you're working on a job and the dry standard might be 8% in the area that you're working at. You'll be able to program your new E-Tes SD to shut the machine off when it reaches that 8%, or maybe even 9 or 10% and let equilibrium take over after that point. This will also be data logging, and then you'll be able to document it and send it out in a software package upon completion. We'll show you more about that. I should mention real quickly that we do have 10-foot extension cords. Even though this is just a 4-foot cord, you can add 10-foot extension cords to it at your length, so you're not limited to just right in front of the E-Tes SD unit with that. The next sensor device that I'd like to tell you about is our air temperature sensor. Again, it comes with a cord. This one is longer, a 10-foot cord, but again, you can add additional lengths to it. This simple sensor will detect the temperature of the ambient air that you're working in. It will not only document it, but will also control the machine. This is done again by plugging it into the receptacle on the front of the machine, marked air temperature, and then you can program the unit upon which temperature you want the unit, the heating element, to turn off. This allows you to prevent overheating in an environment. Coming out the snout of these boxes, you might have 100, 120 degrees, and even more in some situations. But if you don't want the ambient air to get too warm, if you're pumping under carpet, under plastic containment, or just in the air, you can actually set the temperature sensor on your controls here that will turn the machine on and off. For example, maybe you don't want the environment to get over 95 degrees. This unit will allow it to control the machine. It will also document the air temperature. Remember, I told you there's an air temperature built inside. This is a second unit, so you now have two air temperature sensors and readings that you can use. Another sensing device I want to tell you about now is the surface temperature sensor. This particular unit, like the others, plugs into the front of the board, the microprocessing board, the control panel, and then has a device here that it can either be tacked, screwed, or taped to a surface. If you were trying to determine what the temperature of a carpet was, a wood, any substrate that you might be dealing with, you'll be able to do that with this tool. Anybody that is using the E-Tes technology or directed heat drying, you'll recognize the importance of monitoring surface temperature. Our evaporation potential calculator is a device that measures vapor pressure differential. The warmer the wet material of flooring, in most cases, the quicker it's going to dry. And this will allow you again to monitor that. We'll have more information about that, but that is another extremely important device and sensing tool. And again, remember, as it's doing this, as if you have all of these different sensors in there, it is also documenting them, data logging them, that you'll be able to chart with your invoicing later. We also have, that Greg will explain more later, is a radio frequency exhaust controller. You'll take a standard air mover, be able to plug this into a wall, and again sense it at a temperature setting, be able to exhaust the room with this device. To utilize the data logging and charting feature of the new E-Tes SD, you'll need to take a standard flash drive, thumb drive card, insert it into the port on the front of the microprocessing board control panel here, and then it will automatically download all the information from that job onto the flash drive. You'll then be able to disengage the flash drive, take it back to your office computer, laptop, whatever you choose to, and be able to print out documentation sheets. And so you can submit these with your invoicing to verify drying standards, drying times, etc. with it. There'll be more explanation on that, and that is available as a purchase. There's a one-time fee that you will pay for the data logging and charting capabilities with that. You can get more information from your local Interlink distributor. Well, again, I'm really excited to introduce you to the E-Tes Smart Dry, or SD as we'll refer to it. This unit uses the principles, as all of the other test units have, of directed heat drying. You can now not only dry faster using directed heat drying, but the new SD unit will allow you to monitor the materials and the environment that you're drying in. It will allow you to control it with temperature settings and moisture content settings and surface temperature settings. And then best of all, it data logs it and then charts it. So you'll be able to submit excellent documentation with invoicing, again assuring that you're going to be paid fairly and adequately for the equipment that you're using. Hope you'll get with your new Interlink distributor if you haven't purchased one already, and learn more about the SD or the E-Tes Smart Dry. Thank you. I'm going to let Greg come on now and go through the programming of it.
Hi, I'm here to give you more information on how to operate your E-Tes SD unit. If you read your operator's manual, I have a more detailed explanation of what we're going to go over, but this should give you a basis of understanding to start your unit as soon as you receive it. First thing we want to go over is the power cords. Each power cord for our E-Tes SD units has a ground fault circuit interrupter. When you plug the unit in the wall, you will push the button on the front to set the GFCI, then test to make sure that it pops, reset it, and you're ready to go. With the 120 volt E-Tes SD, there are two power cords that must be connected. Simply plug your cords into the wall outlet and then connect the cords to the E-Tes unit. The amp draw of the unit requires that each cord be on separate circuits. When you turn the power switch on, the green light will indicate if you are on separate circuits. If the green light lights, you are on two separate circuits and you're ready to go. If the green light does not come on, you're on the same circuit and one or both of the cords should be moved to new outlets. The 240 volt version just has a single power cord, and since there's only one cord, there is no dual circuit indicator light. When your cords are properly connected and you turn the power switch on and the green light illuminates, the display screen will come on and quickly scroll through the first 6 screens until it gets to the main screen. The first screen is the booting screen showing the software version being booted up. The second is simply a welcome screen welcoming you to Smart Drawing System. Then it'll show the serial number and software version screen and the serial number and job screen showing you the number of jobs on which the unit has been run. A new job is created each time the power switch is turned on. Okay. Next is the menu screen showing you that you can use the up and down keys to scroll through the menu. Then the menu enter screen showing you that you can enter select to enter any menu screen. And finally it'll get to the main screen. When the main screen is displayed, the unit is on and ready to operate. The main screen displays the present level of relative humidity and the current sensor readings for air temperature, surface temperature, and moisture 1 value. If the sensors are not connected, the screen will display the default values of 0. If there is a shutdown condition reported from one of the sensors, a warning screen may be displayed in place of the main screen. When the conditions return to normal, the main screen will again be displayed. When the main screen is on and the unit is ready to operate, the power indicator light will turn on. If the unit is operating properly and in the heating mode, the heating light will also come on. At this time, since we don't have the air mover turned on and there's insufficient airflow to turn the heater on, the airflow light has come on and turned the heating light off. If the system was to overheat, the overtemp light would come on. So in normal operation, we will only want to see the power and heating light on, and the 2 red lights below it should not be on unless there's a situation that's turning the heater off. If we turn the air mover on at this time, you'll see it return to the normal heating mode. Now with both green lights on, the unit is heating properly. Once the main screen is displayed, you can scroll through the different menu selections by using the up or down key. When you go up, the first screen to be displayed is the current date and time. If you press select, you can enter that screen and change the date as needed. The next screen shows you the total system hours. This is the total amount of time that the system has been operating. The next screen shows the current job time. This is the time since the switch has been turned on and off last. As we said before, each time you turn the switch on and off, a new job is created. The next screen is the airflow setup screen. This allows you to calibrate your airflow switch so the machine will turn on and off properly with the proper airflow. The next screen is the remote setup screen. This allows you to adjust the temperature at which your remote fan control will turn on and off. This is your internal temperature and relative humidity screen. This is your moisture 2 value screen. You can press select to enter and calibrate your remote moisture probe for number 2. This is your moisture 1 value screen. You can again press select to enter this screen and change your remote setting for that moisture probe. Here is your surface temp screen. Here is your air temperature screen. And we'll return to the main screen. Now the air temperature screen shows the current air temperature probe reading. Since at this time there is no probe connected, it's reading the default value of 0. If we connect a probe, the temperature will go up to the current room temperature reading. Now if you want to adjust your set point in which the machine turns on and off, controlled by the air temperature probe, simply press select to enter the screen, and you can use your up and down keys to scroll to the different temperature and set the temperature, and again press select to enter your selected temperature. This is the surface temperature screen. It's displaying the current probe, surface temperature probe setting. Since there is no probe connected, it's displaying the default value of 0. Once you connect a surface temperature probe, the setting will change to the current temperature of the probe. If you want to adjust the shutoff temperature of the surface probe, simply press Select to enter the screen and use your up and down keys to adjust the temperature to the desired set point. Then press Select to enter the desired temperature. Okay, this is the Moisture 1 value screen. Since there is no probe connected, it's showing the default reading of 0. When I connect a probe to the Moisture 1, it will start to read the sensor. It takes a few seconds to acclimate itself, but once it gets to a certain point, you'll have the current reading. Now, if you wanted to set the temperature or the moisture level at which it turns the machine on and off, simply press Select to enter the screen, and you can use the up key or the down key to set the proper percentage. At this point, we'll set it at 15%. Enters. And now our setting is set for Moisture Value 1. The Moisture 2 value screen is similar to the Moisture 1 value screen. Since there's no probe connecting it, at this time it's reading 0. Once you connect the probe, it'll take a few seconds to acclimate itself, but will display the current probe reading. To set the temperature at which Moisture Value 2 shuts off the machine, simply press Select to enter the screen and use the up key to set your set point. And press Select to enter. Now at this point I've entered 15% as my set point. When the Moisture 2 level falls below 15%, it will shut the heater off. This is the remote setup screen. This will allow you to set the temperature in which your E-Tes SD will send a radio frequency signal to your remote fan control to turn the fan on and off to set your desired room temperature. The air temperature probe must be connected for the remote control to work. To set the point at which the fan turns on and off, simply enter Select to enter the screen and use your up and down key to set the temperature where you want the fan to turn off, and again press Select to enter the information. This is our remote fan exhaust control. As we mentioned before, the unit will send a radio frequency signal to this unit to turn the switch on and off and control your exhaust fan. To use this, it must be calibrated for your machine. To calibrate the system, simply press the reset button as you plug the remote control into the wall. Then go into your remote sensor setup screen on your E-Tes, and when you set the temperature, it will send a signal to calibrate your switch. The airflow setup screen was designed to allow you to recalibrate the airflow sensor. The airflow sensors may get some bend memory over time and change its set point. To set the airflow turn-on temp setting, press Select to enter the screen. It will give you the instructions to turn the fan off, and the numbers here show you the current resistance reading of the airflow switch. Now we will enter down to enter the low setting. Now we will turn the fan on, and when the fan is up to speed, as you notice, these numbers will start to change. And when the fan gets to the point where the heating light comes on, we will press down and it'll set our trigger point, and we press Select to enter the information. Our airflow sensor is now calibrated. A couple things to remember when using your E-Tes SD. The first is that once you've set your shut-off points for each of your probes, your air temperature, surface temperature, moisture probes, the unit will remember those set points even after you turn the machine on and off. So it's easy to set your set points at the shop before you take the unit out to the job, and you don't have to reset it at every job. However, if you were to turn the unit on with your moisture probe disconnected and then plug the moisture probe in and get a measured reading, it's going to mess up the set point. So you'll have to turn the unit on and back off again to recalibrate the moisture probe reading. One important thing to remember is that the programming information that we showed is exactly the same for the 120 volt and the 240 volt units. I hope you found this information helpful. If you have any questions, consult your operator's manual or contact your test distributor for more information. Thank you.